Hi guys, here's my first attempt at making a power video. What is a power video? I'm attempting to do in 10 minutes just a quick sum up what happened in Unit 1. Unit 1 was an intro all about variables. We looked at categorical variables versus quantitative variables. I'm going to start by investigating categorical variables. We talked about a conditional distribution versus a marginal distribution. What I have right here is I have a frequency table. You can see, you can imagine if I had 1,000 people, or it doesn't even matter how many people I had in the school. If I take everyone's names who go to this school, put their names in a hat, I pull 500 names out, I'm going to record what kind of computer they own. So I have none, PC, Macintosh. Right here, this is a marginal distribution describing the type of ownership of a computer. Now, over here on the right-hand side, this percent, this is, if you see a percent with it, it's called a relative frequency distribution because it's like it's all relative to out of a percentage, 100%. Okay, marginal distribution, we're talking about one variable, what's going on for that one variable. What is a conditional distribution? So I have a conditional distribution here. This is where you are relating two categorical variables. So I have males and females, and I have the type of computer they own. So you can imagine now, same school, same hat, I pull out 500 people's names, and instead of just looking at what type of computer they own, I record their gender as well. Now ignore the decimals on the side, okay? Marginal distribution, there's two marginal distributions here. There's the distribution of what they own, which is this outside column here, the 85, 60, and 355. And then there's the marginal distribution of their gender, 306 and 194. Now, what is a conditional distribution? There's a couple different conditional distributions. I am going to look at the conditional distribution of who owns what PC or what kind of computer for males right now. Where did this 0.14 come from? This is given that they are males. So now I'm just looking at those 306 males. So all the males are in one hat now. I pull out 306 names. 14% of them, 43 divided by 306. And I just rounded to the nearest hundredth. On the AP exam, you should obviously do 3 or 4. I'm just attempting to do this a little quicker. 38 of the 306 males, which is 12%, owned a PC. And about 60% of the males owned a Mac. I can now look at the females. Okay, so now again, I'm looking at the conditional distribution of what kind of PC people own for just females only. You can imagine I have all the females' names in a hat. There's 194 names I pull out. 42 of them own nothing. 22 own a PC. 130 own a Mac. We get these percentages, and I calculated this quickly. So I got about 21%. Here I got about 11%. And then here it was approximately 67%. So what's the point of doing this initially? The point is just to investigate the relationship between them. And then eventually when we get to chapter 11, that's when here we would do a chi-square test of independence. Is what you own for a computer independent of your gender, okay? But in Unit 1, they just want you to investigate this, and they may just want you to investigate this on a number 1 problem. So I did with a graph here. And on the left-hand side here, I have the total percent. And then on the x-axis here, I have males and females because that's what I investigated. And you could do it the other way. You could do it for Mac, PC, and nothing and investigate the conditional distribution of gender for what kind of computer they own. And I would need a key to make it official, but I just said, hey, the blue, what did I notice? That's going to be my none category here, that 14%, and this would relate to 14%. Now the green here you see is 12%, so I just added an extra, what I thought was about 12% on top of that blue there. And if you go over 12 plus I think is it 11, or no, 12 plus 14 gets you 26%. This mark right here is approximately halfway to 50. And the rest makes up the Mac owners. And you can see that this distribution is pretty equal. So right now, based off the graph, we have evidence that it's pretty independent. There's no true relationship between gender and what kind of computer they own. If you saw the red being really short, and the red being really long over here, and the blue being really long over here, and the red being really short over there, then we would have evidence that they are not independent, that there's a relationship. And then we would have to run chi-square test for independence to confirm. Okay, moving on to quantitative variables. When we plotted quantitative variables, we plotted a dot plot, a stem plot, or a histogram. A dot plot is the easiest thing to do if there's not a lot of data. A stem plot is nice because it really, or a stem plot should be used, that's another nice one I should say. And it should be used when you have a small sample size. And then a histogram is used when you have a large sample size. You need to go back and make sure you review how to do those three. I'm not going to go through them with you. You do, whenever you're asked to interpret a histogram or describe a histogram, you need to remember SOCs: shape, outliers, center, and spread. Okay? Remembering with shape that we have a skewed distribution versus a symmetric distribution. A skewed distribution is where we have the tail on the left, and that would be skewed left. If we have a tail on the right, that's skewed right. And then mostly symmetric is where you can fold it in half, it's going to match up. I spelled outliers wrong. I always would talk about that with my Shaquille O'Neal. We're measuring shoe size, we make a dot plot of shoe size. Shaquille O'Neal comes in, there's a big gap, and there he is with his shoe size. You cannot say it's a for sure outlier unless you test it. If you're not asked to test it, they will ask you on the AP exam to use an outlier rule to confirm or to test it. You can just speculate. Then you have to say it looks like there's an apparent outlier or a possible outlier at a certain point. The center is going to be the mean or the median, and the spread is going to be the standard deviation or the IQR. Now, when you choose your numerical summaries, you need to choose. So when you're using SOCs, shape, outlier, center, spread, or if they ask you what would be the best numerical summary, you need to think about, do we have a skewed distribution or do we have a symmetric distribution? If we have a skewed distribution, we need to use the median and the IQR. Why do we have to use the median and the IQR for a skewed distribution? Well, because outliers, that skew is skewing the data. It's throwing the mean and the standard deviation off. So you do not want to describe the center with the mean. It is chasing that tail. The mean chases the tail. Pause it for a second if you have any questions about this, and make sure you ask me in class. Now, the mean and the standard deviation is a great center and spread if you have a symmetric distribution. Okay? That's what you're going to use for the center and the spread when you are describing or interpreting a graph. Okay, so make sure you understand again, median, IQR. Why do you use that for a a skewed distribution? You can never take the standard deviation as a measure of spread and the median as a measure of center. These are married. If you choose to take the center as a median, then you have to choose to use the IQR as a spread. If you have questions on how to compute this at all, make sure you ask me. More than likely, they are going to give you a mini-tab output with all of this, and you just have to interpret it and say why something is the way it is. Or you need to compare distributions. So that leads me to my last minute and a half and my last slide. I have a side-by-side box plot of these two distributions of actors versus actresses. So we're looking at gender and who has won an Oscar from 1970 to 2001. It is more than likely that you will be asked to compare on the AP exam. And a big thing is when you are comparing quantitative data, you need complete sentences, you need to talk about SOCs, and you need comparative words. What does that mean? Greater than, less than, approximately. It needs to be in full sentences. So I'm going to do this now and attempt to do it in 45 seconds here. The distribution of actors who have won Best Actor, or let me start over, excuse me. The distribution of Best Actors is approximately symmetric, excluding an outlier at around 79. This is approximately equal to an actress who was also an outlier at 79. However, there's an outlier that is greater than 79. It appears that there's an actress who has an outlier at 80. There's also an outlier that is less than the male actor outlier, and that outlier is at 60. I don't think there's going to be that many outliers on the actual A/B test. Side note. Okay, I'm going to keep going. So I talked about the shape of the actors. It appears symmetric without the outlier. The actresses appears symmetric without the outliers as well. There is one outlier in the actors, which is less than the 3 outliers of the actresses. However, they are all above the age 60. Okay. Next, I need to talk about the center. The median of the actors is about 41, which is greater than the median of the actresses, which is about 39. Again, I use that word greater than there. Okay. The spread, the IQR, is approximately 15 for the actors. And for the actresses, it looks like it's approximately 10. So the spread of the actors is greater than the spread of the actresses. I talked about shape. I talked about outliers. I talked about center and spread. I fumbled on my words a bit, but I'm trying to finish this up for you guys, and I'm sorry. Let me know if you have any questions. It needed to be in complete sentences. One question you might have is, I called this symmetric, but I did not use the mean and standard deviation. Why? There's no data that gives that to me. I'm given a box plot. If I'm given a box plot, they're going to want you to use the median and the IQR to describe the center and the spread. Let me know if you have any questions, and thanks for watching.